So this question is a two-step question, and it really helps if you can read it and identify what you're starting with and where you want to end. So what we're starting with is we are given the wavelength of a photon, and we're going to have to calculate the energy from the wavelength. And we're going to do that the same exact way that we did in the previous question. We're going to capitalize on the fact that the frequency is equal to the speed of light divided by lambda. Multiply that by Planck's constant, and that's going to give us the energy. But this gives us the energy of one photon. And we need to know how many photons are necessary to make up 4.184 joules of energy. So, at this point in the class, all these look like kind of arbitrary numbers, 1 gram of water and 1 degree Celsius. But this is actually the specific heat of water. And we're going to talk about that right before we get into our section on thermodynamics. So you'll return this idea, and this number here is actually a number that you're probably going to have to memorize when we get there. You don't have to memorize it now. But the question is this: if each photon is about 2 times 10 to the negative 28 joules, how many of those photons do you need to make up 4.184 joules? And so to answer that question is we take the number of joules we have, and we are going to solve for x, which would be the number of them that it would take to make up that. And so I'm just isolating x here. I put 4.184 here. I take the number of the amount of energy in joules, divide the two, and I come up with 2.11 times 10 to the 28 photons. Now that's a lot of photons. That's more than a mole of photons. Remember, a mole would be 6.02 times 10 to the 23rd. So that's a lot of photons. But there are a lot of photons out there, so it's not difficult. And so when a microwave is working, it is actually generating a tremendous amount of photons to heat just even 1 gram of water. This is the equivalent of 1 milliliter of water, 1 degree Celsius.